Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Assalamu alaikum. I am Atif Hassan. Today our lecture is for LNMDCAT, and that is lecture number 7 based on electronics. Okay, dear students, electronics is the branch of physics in which we study those devices which is using electron for their application by means of their flow, as well as control the flow of electron. So electronics is the study of control and flow of electron in semiconductor devices is called electronics. Dear students, according to PMC syllabus, we have to cover a few topics, that is p-n junction, half wave rectifier, full wave rectifier, and transformer. Transformer is done in the lecture number 7, and now we are going to start from p-n junction. Okay, before going to p-n junction, we will discuss a bit about the group 4 elements. Dear students, we have group 4 having elements like silicon and germanium. They are semiconductors and are called as intrinsic semiconductors. By intrinsic semiconductor, we mean they are extracted from the core of earth and are naturally occurring elements. Okay? So now what is p-n junction? P-n junction has definition like when a p and n type of material are combined, formed a structure p and n as a whole connected through a junction called as p-n junction. If we take p type of material, n type of material, and combine through a particular process in molten form, they will be solidify and will give us a structure called as p-n junction. They are connected to a point called as junction, and one side of it is p type and other side of it is n type. So as a whole it is called p-s junction. First of all, we are going to discuss a bit what is n type. If we combine group 4 elements and group 5 elements, the result we get will be n type. Group 4 is pure semiconductor like silicon and germanium, while group 5 act as an impurity, and this process of adding impurity to the group 4 is called as doping or doping. Okay, if we combine group 4 with group 3, then we will get p type of material. Okay, we will discuss in a few moments that what is n type and what is p type. For example, if we combine aluminum, that is from group 3, with silicon, what will happen? Silicon has 4 outermost electrons and aluminum has 3. So in the structure of silicon, if we put aluminum as an impurity, aluminum is from group 3 and having 3 valence electron in its outermost shell. So aluminum will share each of electron with the adjacent silicon of the crystal structure. So one atom of aluminum from group 3 will be shared here with silicon, other one will be shared here, the third one will be shared here, and with the fourth one, aluminum has no electron to be shared. So this is called as deficiency of electron, and this deficiency of electron is called as a hole, and hole is taken to be positive. So if we put impurity aluminum in the silicon structure, we will have an extra hole, that is deficiency of electron, and due to this extra hole, the whole structure is taken to be what? Positive. I didn't mean that it will be positive. As a whole it will be neutralized, but by adding impurity, one positive charge will be in excess in the crystal, and due to that excess of positive, this whole structure now called as p type. Similarly, if we put phosphorus, that is from group 5 with silicon structure, what will happen? It has 5 outermost electrons. It will share one of electron with the adjacent silicon, second one here, third one here, fourth one here, and if you see, there is no electron for this fifth electron of phosphorus to be shared. So by putting impurity of phosphorus, one electron will be in excess in the crystal, and due to this excess of electrons, such kind of material is called as n-type of material. Now if we combine this n and p type together, what will happen? If this is n, here in n type, one electron will be in excess, so we can say that electron will be in majority carriers for n type, and holes are minority carriers for n type. And similarly for p type, holes act as majority carriers and electron as minority carriers. So if this is n type, electrons will be large in number. Let's say electrons are denoted by the black dots and holes are denoted by the red dots. So electrons are in excess, are in larger number, while holes are in smaller number. While in p type of material, electrons are minority charge carriers and holes are majority charge carriers. When they are combined, this point is called as what? Junction. So what will happen by combining these two? The extra electron or the majority carrier or larger number of electron in elements start to diffuse to the p type material. So when electron shifted here, there will be produced a negative ion near the junctions of p type side, and when electron jump from here to there will be produced a positive ion near the junction. So this junction will have positive and negative ions, and from this positive ion an electric field will be generated towards the negative, and there is separation D between them. So we know that whenever there is separation D between 2 points, there is an electric field E, there exists a potential E is equal to V is equal to E into D. So there produce a potential here. Which kind of potential? This is called as potential barrier. Initially when the electrons start to flow, what will happen? The electrons start flow from N to P, and it is called as diffusion current. They will flow up till when the number of electrons become in N becomes equal to the number of electron in P. Diffusion current. And after accommodation of positive and negative ions here, an electric field will be generated, and we know that if we have an electric field like this from positive to negative, and we have electron inside the field, the electron by itself will move in opposite direction to the electric field. But now here the direction of electric field from positive to negative, electron by itself cannot move from N region to P region. So electron is restricted to move from N to P due to this electric field, and due to this electric field a potential is created, and this potential is called as potential barrier. Note that the properties of potential barrier are: there will be no free charge carrier, either hole or electron present in the potential barrier. Note that there is no free charge carrier like electron or hole present in this region called as potential barrier or depletion region. Potential barrier. Okay, so this is called as potential barrier. The value of this potential barrier for silicon is 0.7 volt. If you don't have any idea about this, so silicon first letter is for 7, S7, and potential barrier for germanium is 0.3 volt. One is 0.3 and one is 0.7. For silicon it is 0.7, so automatically you can choose 0.3 for germanium. Okay. Acha ji, dear students, now the next topic is biasing. What is biasing? Biasing is the method of applying battery to p-n junction is called as biasing. There are two types of biasing. One is called as forward biasing and other is called as reverse biasing. Forward biasing is that if we apply a positive terminal to the here we have to write like this. Okay, let's say this is negative terminal, that one is positive terminal. If we apply negative terminal to the end side and positive to the P, then such kind of connection of the battery is called as forward biasing. Now let's see that what will happen here. The electrons in the N region which act as majority carriers will be repelled by this terminal and will tend to flow in this direction. The electron will tend to flow in this direction towards the potential barrier. Now if the negative potential increases with time, the electron will be pushed towards what? The potential barrier, and these electrons will gain potential. Here for silicon, let's say it is 0.7 volt. Initially when we apply this battery, the potential of this electron will become, let's say, 0.1. After that it will become 0.2 and it will increase and will reach to 0.7. So if we observe it here, we know that the electron always tend to move in the opposite direction to the electric field. But from here we are applying potential and want to move this electron or these electron in the direction of electric field. So here 0.7 potential is applied and we are applying potential in opposite direction to the potential gradient or potential barrier. So the potential is how much? 0.7, and if we apply 0.1, then this 0.1 will be subtracted from 0.7 and the net potential barrier will become 0.6. In the similar way it will be increased and will reach to 0.7. If we minus 0.7 from 0.7, it will become 0 volt. So if we increase the potential here and forward biasing, this potential barrier will be reduced and after some time it will be vanished and the current will start to flow. And such kind of application of the battery to the p-n junction is called as forward biasing. So in forward biasing, the current will flow due to electrons of the N region, or we can say that the current will flow due to majority charge carriers of N. So here the current will flow. In other words, now if we connect terminal that is positive of the battery with N and negative of the battery with P, what will happen? These electrons will be attracted by these terminals away from this potential barrier, and these electron will now further be unable to cross this, so the potential barrier will be increased here, and these holes will also be attracted towards the negative terminal. So here the potential barrier will also be increased and the current will be unable to flow due to majority carriers. So in this very case, the current is unable to flow due to majority carriers. So here the current was flowing, so p-n junction behave like a conductor when connected to the battery in forward, and here it behave like an insulator when connected to the battery in reverse biasing. So now here the current was flowing towards right, and here the current is unable to flow towards right. So we can say that p-n junction is such a device which allow the current to flow in a single direction. Due to this ability of allowing the current to flow in a single direction, this p-n junction is called as what? A diode. The second name of this p-n junction is what? Diode. Sorry. This is what? Diode. Diode's definition is that a device which allow the current through a single direction. Now we cannot draw this very block diagram every time, so we have to use a symbol. This is symbol of a p-n junction or diode. This side, which is base of the p-n junction or diode, this side is called as P and that side is called as N. And if we connect positive with P and negative with N, then it is forward biasing and the current will flow, and vice versa for this one. Okay.